what we're going to do is we are going to multiply and divide rational expressions. And again, factoring is key in these. And what we want to do is we want to factor the numerators, the tops of the fractions. We want to factor the denominators, the bottoms of the fractions. And then we can do what we did with the simplifying. I'll still say the same thing. Do we have anything exactly the same in the top and in the bottom? So as we look at this first one, for x squared minus 4, what we're going to do is we're going to factor. And x squared minus 4 is our difference between two squares. Factors of x squared are x and x. Factors of 4 are 2 and 2. Difference between two squares, different signs. And our denominator of that same fraction. We're lucky there's no number in front of the x squared term, so we can factor it. And x and x. Factors of 6 that combine to be 1. It's either 1 times 6 or 2 times 3. When I say combine, I mean add or subtract 2. So 2 and 3. And then it's going to be plus 2 minus 3. We are going to multiply by the second fraction over here. And what we've got is we've got to look for greatest common factors. And one of the ways that I know that we need to look for a greatest common factor is we have a number in front of the x squared term. It doesn't mean that we have a greatest common factor, but it really is something that I want to look for before I do a whole bunch of work. And luckily on 3x squared plus 15x, not only do we have a 3 as a greatest common factor, but we also have an x as a greatest common factor. So 3x squared times 3x times x is 3x squared, and then 3x times 5 is 15x. We also can find the GCF in the denominator, which is 6x. And when we factor out of 6x, we're left with x times 2. 6x squared divided by 6x is x. 12x divided by 6x is 2. And then we can ask ourselves, do we have anything exactly the same in the top and in the bottom? Well, we have x plus 2 and x plus 2. Remember, x plus 2 divided by x plus 2 is 1. But they're canceling out. We also have an x minus 2 here, along with an x minus 2 there. That cancels out. And then I don't see much more, but actually as I'm looking here a little bit closer, x divided by x is 1. And so nothing's going to cancel out with the x plus 5 and the x minus 3, but can we simplify 3/6? 3/6 becomes 1/2, so we've got 1 times x plus 5, that's still up here in the numerator. Let me circle this there so to show that we've got that. And then 3/6 is 1/2. We still have this x minus 3 there. And no, you don't have to write the 1. And we can leave it like that. So very similar to what we were doing yesterday, Gracie? Well, because x divided by x is 1. They can cancel out. You see it? Okay. So let's try another one. The process is still the same. What we're looking for is we're looking to factor. And then, do we have anything exactly the same on the top and on the bottom? We saw in that last problem that 3/6, that wasn't exactly the same on the top and the bottom, but we can still simplify. And as we look at our first fraction here, our first numerator in our first fraction, again, the GCF of 2x. And when we factor out of 2x, x plus 6. In the denominator, our common factor is a 4, and we're left with x plus 2. By the way, I'm not sure I said it on the last screen, but when we multiply fractions, we multiply the tops together, and we multiply the bottoms together, and then we divide. So we're avoiding doing a whole bunch of multiplication by canceling. And as we look over here at x squared minus 4x minus 12, nice that there is no number in front of the x squared. So we're left with x and x. Factors of 12 that combine to be 4, well, 1 times 12, 2 times 6, 3 times 4, it looks like 2 and 6 are going to work for us. And it's going to be plus 2 minus 6. And then finally, x squared minus 36. Our favorites, and I might have to add sarcasm in there. Difference between two squares. X squared is x and x. 36 is 6 and 6. Difference between two squares, different signs. And once again, what we're looking for is, do we have anything exactly the same on the top and on the bottom? Well, when we start looking closely, do you see anything? X minus 6. X plus 6. X plus 2. So all of our parentheses cancel out. As we take a look here, and some of you don't even need to take a look there, can we simplify anything with what's still remaining? 2/4 is 1/2. So it's 1/2 x. The x is in the top. It's in the numerator of the fraction, so it needs to stay in the top. No, you don't have to write the 1. If you prefer, we're left with x divided by 2. Pause here. When we look at problem number 3, again, good practice. It's really good practice to factor. The one thing that I want to say on the first fraction is, don't change the order of anything. It says 9 minus x squared. That is the difference between two squares again. And 9 is 3 times 3. And x squared is x times x. Difference between two squares, different signs. Down here in our denominator, looking at the GCF, whenever we see a number in front of the x, the biggest x term, and that didn't come out very well, but the x cubed, the highest degree term, look and see if we have a GCF. And luckily, we do. And not only is it 2, it's 2x squared. And when we factor out a 2x squared, we're left with x minus 3. Over here in our second fraction, what's our GCF? 4x. When we factor out a 4x, here's another little thing to remember. 4x squared divided by 4x is x. 4x divided by 4x is 1. We have to have that 1 there, and some of you are forgetting the 1. In this denominator, no number in front of the x squared, which makes it a little bit easier to work with. X squared is x and x. The only factors of 3 are 3 and 1. And we need to combine to be positive 2. So as we look a little bit more closely on this one, do we have anything exactly the same on the top and the bottom? The x minus 1s? So let me ask you this. Can you recognize that 3 plus x, 3 is positive and x is positive, and x plus 3, x is positive, 3 is positive, are the same thing? They're written in different order, but they are the same thing. So if you can, we can cancel that out, those two values out as well. Now, I don't always do this, but I'm going to rewrite what I have left right now. And I'm going to put the 4x, which is coming from here, and 3 minus x here, divided by 2x squared times x minus 3. We've canceled some factors out. We still have some left. When we look at it from a smaller perspective here, can we cancel anything else out? We've got some more stuff to cancel out. In other words, what's 4 divided by 2? It's 2. X divided by x squared. Well, if you're unsure, remember, here's x and there's x squared. Not very much to write out. When we cancel something out, we're left with an x down here in the denominator. And we still have the 3 minus x and the x minus 3. But notice, they're similar, they're not quite the same, but can't we make them the same? And I'm going to recommend that we change the sign in the numerator, because then we don't have to go through all that no negatives are allowed in the denominator. And to shorten that up a little bit, all that I do is I'm going to change the sign on the -2. And if we change the sign on the -2, we need to keep the equation the same, so we're going to change the sign on the 3, which means that we're going to change the sign on the x. And if you need to, it just depends on if you need to. You could rewrite this as x minus 3 there. And over here, x times x minus 3. You might not have to do that step if you can recognize that we have something exactly the same on the top and on the bottom, which is the x minus 3 divided by x minus 3, which is 1, and that leaves us with -2 over x. Hopefully I left enough space for you as we flip over here to the next. Problem number 4 looks like this. In terms of the online assignments, every online assignment problem looks like this. Just want to tell you that ahead of time. But in terms of approaching this problem, I would write it in a different format. I would translate it right away into x squared plus 2x minus 8 divided by 8x minus 16 divided by x squared minus 16 divided by 2x plus 10. Those two expressions right there are equivalent. They mean the same thing. They're just using a different format. So when you're working on your online assignment, I recommend that you translate the original into a format where you've got that actual division symbol in there. But let me remind you that when dividing, don't ask why. Flip the second one and multiply. That's a little saying that many people use to help them remember how to divide fractions. So the first fraction in here, it's not going to change. But when dividing, don't ask why, flip the second one. So 2x plus 10 is going to go on top. X squared minus 16 is going to go in the denominator on bottom. Flip the second one and multiply. So once we know that, it's going to be the same as the previous 3 that we've done already. We're going to factor everything. We're going to look for things that are exactly the same on the top and the bottom. And then we're going to cancel out. X squared is x times x. Factors of 8 that combine to be 2 are 4 and 2. It's going to be plus 4 and minus 2. GCF of 8. And we're left with x minus 2. We've done the work. When dividing, don't ask why, flip the second one and multiply. We flipped the second one, so we're still in the multiply. We're going to factor a GCF now of 2 times x plus 5. And then finally, the one that seems to be the most difficult for us most recently is x squared minus 16. So x squared is x and x. 16 is 4 and 4. Difference between two squares, different signs. And then we need to ask ourselves, do we have anything exactly the same on the top and on the bottom? I'm not sure if I heard what you said. X minus 2 and x minus 2. That should be exactly the same. We also have x plus 4 and x plus 4. So again, some of you may need to rewrite and some of you might not need to rewrite. But at this point we have 2 times x plus 5 divided by 8 times x minus 4. Can we do anything else? The 2 8s can be simplified to 1/4 if you prefer. And you don't really need to write the 1. So it's x plus 5 over 4 times x minus 4.
Can you leave the 1 there?
Leave the 1. Doesn't bother me. So as we get close to finishing, again what I need to stress, because for some of us, we don't like fractions, and therefore because we don't like it, we kind of block it out of our lives. I don't like them, so I'm not going to do them. Or I don't like them, so I'm going to let my calculator do them. Well, we've gotten to the point where we can't always let our calculator do them. So what I want to stress again is, when dividing, don't ask why, flip the second one and multiply. So back over here on our problem, we've got 9x squared minus 1 and 3x squared plus 7x plus 2. We're not going to change that. That's the first fraction there. But when dividing, don't ask why, flip the second one. X squared minus 5x minus 14. It was in the denominator. Now we're going to move it up to the top, also known as the numerator. And the 5 minus the 15x is going to move down to the denominator. And we're going to multiply. So we factor. And before I get too far into the factoring, I'm going to start with the 3x squared plus the 7x plus 2. Because I need a little bit of space. I'm going to use the slide divide method. There's probably people in this class that know how to do the airplane method, and I need to defer to help each other on that method. I'm going to slide the 3 over. When we slide the 3 over, we get x squared plus 7x plus 6. So now we don't have any number in front of the x squared term, so that works well. And we get x and plus 6 and plus 1. 6 times 1 is 6, and 6 plus 1 is 7. We slide. Now we need to divide. Divide that by 3 and divide that by 3. So this first parentheses becomes x plus 2, because we can simplify that. And then we can also do the bottoms up here. We get 3x plus 1. And then let's put that back into our problem now. So we have x plus 2 and 3x plus 1. On our numerator, 9x squared is 3x times 3x. 1 is 1 times 1. Difference between two squares, different signs. On our other fraction, we've got x and x. And factors of 14 are 1 and 14, 2 and 7. We need to combine to be 5. So we're going to use the 2 and the 7. It's going to be plus 2 and minus 7. And finally, in our denominator here, do we have a GCF? Don't change the order. We do have a GCF of 5. When we factor out of 5, 5 divided by 5 is 1 minus 3x. Again, don't forget the 1. Because we were dividing. Yes. So now that we've done this much, we've got all the factoring done. Do we have anything exactly the same in the top and the bottom? X plus 2. Three x plus 1. And again, you may or may not have to write this again. Some of you can change your signs the way you need to on this. But we have, right now, left 3x minus 1 times x minus 7 divided by 5 times 1 minus 3x. And we do have one more thing, terrible math words, that can cancel. And that is the 3x minus 1 and the 1 minus 3x. But before we can change them, we need to change some signs. And this time I am going to change the negative on the 5, which will change the negative on, or the 1 to a negative, and change the 3x to a positive. We kept the equation in balance, so to speak. And you decide whether you need to write this over one more time. But we have 3x minus 1 times x minus 7 divided by negative 5. And if I change the order a little bit, we can write it as 3x minus 1. And then what we see is, do we have something exactly the same on the top and the bottom? We sure have something exactly the same on the top and the bottom. And then we can finish with x minus 7 divided by negative 5, and I'm wrong about finishing because we're not allowed to have a negative in the denominator. So once again, we need to change the sign, change the sign, change the sign. Negative, really, if I were a better teacher, I would say opposite every time I said negative. But it's a hard habit to break when I learned negative. But really what a negative symbol is opposite. So if I write it a little bit better, negative x plus 7 divided by 5. So the nice thing about simplifying rational expressions with multiplying and dividing is we can put all sorts of different types of factoring problems in here. So it's a really good practice of factoring and multiplying the fractions, also known as rational expressions. And one last time today, we are going to factor. This one, again, is multiply. Remember that we only have to flip the second one when we divide. We don't have to flip on this one, which will save us a little bit of space and time. But we have some other issues in this problem. But we'll start here with x squared plus 4x minus 5. And we get x times x, and then 5 and 1. And to combine to be positive 4, it's going to be plus 5 and minus 1. Down here in our denominator, x to the 4th is giving some people a little bit of trouble as well. But when we factor this, we can start to break apart x to the 4th. And x to the 4th is x squared times x squared. And 16 is 4 times 4. Difference between two squares, different signs. But the thing about this is, we can factor more on that. Which one do you think we can factor? The minus one. It's difference between two squares. Difference means the answer to a subtraction problem. We can factor this. So we still have our x plus 5 and our x minus 1. But we can factor. X squared is x times x. 4 is 2 and 2. Difference between two squares, different signs. Don't forget that we still have the x squared plus 4. And then as we look over here at our next factoring, our next rational expression here, we're going to factor by grouping. And there's a group here, and there's a group here, and I'm going to do a little bit of work here, and then I'm going to bring it down there. Well, the GCF in the first group is x squared, and we're left with x plus 2. There's a GCF in our next group of 4, and we're left with x plus 2 again, which we always hope happens. And then what we see is that we've got x plus 2 here and x plus 2 there. So x plus 2 is in common in both groups. And then we have x squared plus 4. What's left over from the first group? X squared. What's left over from that second group? The 4. And finally, another one of your personal favorites. Again, I haven't got my sarcastic voice yet. x cubed minus 8. The cubed problem. Whenever you see an exponent of 3, if we don't have a GCF, we need to think cubes. And when we factor that, we're going to take the cube root of x cubed, which is x. Take the cube root of 8, which is 2. Same sign, opposite signs, always positive. And x cubed divided by x is x squared. 8 divided by 2 is 4. Remember, we already have the signs in there. X times 2 is 2x. And then what we're looking for is, do we have anything exactly the same in the top and in the bottom? Well, I see x squared plus 4. Thank you. But it's not looking like there's much else that's gonna cancel out. We don't have anything else that's exactly the same as the top and the bottom. So it looks like we're left with x plus 5 times the quantity of x minus 1 divided by x minus 2 times x minus 2 times x squared plus 2x plus 4. I'm fine if you write it that way. But if you would like, we can condense it down just a little bit more. As x minus 2 squared times x squared plus 2x